because as we all know that the fossil fuels are finite resources, so they're going to exhaust after a certain point of time. So definitely we need to seek for certain alternatives, and biorefinery processes could be developed as a sustainable alternative to this. But having said that, biorefinery is always a complex process, so which has several limitations which need to be addressed so that the product that we are interested to produce has to be commercially viable. Right? So the next problem which I thought needs attention is the harsh production methods. So traditionally chemical and physicochemical and thermal based approaches are used for valorizing or producing some kind of products. So always wherever possible we need to go for milder treatments using biocatalysts such as enzymes produced from microbes. So that is what we specialize in. We produce in-house enzymes for valorizing the waste. And the other point that I want to highlight is the environmental hazards which is caused by the plastic pollution. So this is again a problem at global level that needs immediate attention, and we seek to provide certain biodegradable, non-toxic alternative to this plastic that we have currently in the market. So coming to the limitations, first challenge towards the first step of biorefining is the choice, availability and the logistics of the raw materials. So biorefineries run by biomass. So biomass is the backbone for biorefinery. So to even collect the biomass at the commercial scale itself is the first challenge, from the field side to the industry side. So the choice of the feedstock that you're going to select for the product development is the first thing that we need to concentrate on to curb the capex, that's the capital expenditure of the process, which further influences the minimum selling price of the product. The other issues are, in the first place, the lack of technology for process mechanization. By this, I mean to say that there are several bioresources which are still left untapped due to the lack of an efficient technology to convert them into some resource. So developing an efficient and commercially viable technology is the first drawback in biorefinery process. So all of which, kind of influence the capex and opex of the process. And complexity of the process due to the presence of several interfaces. By interfaces I mean the unit operations, the several treatment processes, one after the other. So the series of processes will lead to loss of the raw material or the carbon source itself. So we need to keep the process as simple as possible. So what do we do at Integrated Bioprocess Technology Research Laboratory at IIT Hyderabad is we work on these three different category of products, that is biofuels, mainly ethanol, and biochemicals, such as all this cited here, and the biomaterials. So recently after joining IITH, I started to work on biomaterials for application in various domains. So the essence is to address these points: waste valorization, low cost and eco-friendly routes, wherever possible, and circular economy. So this is one thing which is of paramount importance in today's time, because linear economy is it's a typical conventional way of take, make and dispose, whereas circular economy is more inclusive, where the waste from the primary process can be used as raw materials for the secondary process, and that is how we close loops and arrive at circular economy. And at our lab, we try to work closely with the Sustainable Development Goals set by United Nations. Particularly, we are concentrating on SDG goal number 3, 9, 12, and 13. Yeah, so this is an overview of how we do this process. So we are mainly focusing on agricultural waste or lignocellulosic feedstocks, which can be broadly categorized to be composed of cellulose, hemicellulose, and lignin. So cellulose and hemicellulose, they form the structural carbohydrate portion which are present in the cell wall of these organic wastes, and lignin is regarded more or less as a waste material, a recalcitrant barrier to come access with the carbohydrate fraction, which is of commercial interest for development of several products. But lignin should not be seen as a hindrance, rather it can be extracted and modified, can be valorized to form biomaterials. That is what we are doing at our laboratory. And these complex carbohydrates can be broken down into simple sugars to be used as materials for biochemicals and bioplastics, and also for fuel production, which have applications in all these domains.